the derivation of temperature function and shape function for one-dimensional heat conduction element, which is very basic for finite element and heat transfer problems. Welcome to the Sahasri Academy. Our academy aims to connect between the academic and the industry. The finite element analysis with respect to take one-dimensional bar of node number 1 and node number 2. You know down this node numbers, and the temperature at node number 1 is represented with respect to T1, and temperature at node number 2 is represented with respect to T2. The bar has a length of L. So in this bar, one-dimensional bar element, we have 2 degrees of freedoms, that is T1 and T2. So then the polynomial function, which is to define this temperature function, will have 2 terms. Okay, so that's T equal to A0 plus A1x. So the equation 1, T is equal to 1x, A0 and A1. We can write this polynomial function, the above function with respect to the matrix form. So it can be written as 1x, A0 and A1. So at the node number 1, obviously we know that x equal to 0 and temperature is equal to T1, take it out. Okay, the temperature at node number 2, we take it as T2 at x equal to L. 2 extreme limits, which is maybe useful for the boundary conditions. Okay, so the substitute these 2 equations, node number 1 and node number 2, the two equation into the 1. So you get T1 is equal to A0 and T2 is equal to A0 plus A1L. So now you get this function with respect to the unknown constants A0 and A1. So the equation 3 and 4, we can write it in a matrix form. Once again coming here, this T1, this term, you can write it as a matrix form, so which will be useful to solve the functions. Okay, so T1, T2 equal to 1, 0, 0, 1, L, A0, A1, A0, A1 is equal to, you take the inverse, you take this term here and take T1 here, so you get artificially inverse. So taking this inverse term, you write it here again. So 1 by, you take this matrix as a A matrix, then 1 by adjoint of A, 1 by A modulus of A here. So A modulus, you know how to take it out, 1 into L minus 1 into 0. That's been written here. And adjoint of A is very simple. You reverse this term, L here and 1 here, and take here functions here. So that's adjoint. So 1 by A bar into adjoint is equal to, so you have written this equation. So now the A0 and A1 is equal to 1 by L0 minus 1 and minus 1, T1 and T2. You write this equation and you simplify the equation. Okay. So now you substitute this equation into the equation number A, which we have seen in the slides. So this is equation 6. You write it in the paper and one by one you follow it out. So we'll get all this. Okay. So T equal to 1 by X, 1 by L, 0, minus 1, 1, and T1 and T2. So you substitute this term, 6th equation. Okay. Now you substitute this equation 6 into equation A. So let us see what is equation 6 here we are mentioning. So this equation here, you see the unknown polynomial function term A0 and A1 is denoted with respect to the temperature function, the matrix which relates this unknown to the temperature function. Okay. So this equation you are going to substitute in this temperature function equation. Okay, now you substitute this. you will get the temperature is equal to 1x 1 by L L0 minus 1 1 and the temperature matrix here. So 1 by L 1x L0 minus 1 T1 and T2. So that's the equation here, the temperature function equation. You write it with respect to this and you will get L minus x by L T1 and T2. Okay, so you get this temperature function equation with respect to the shape function. The shape function can be written with respect to N1 and N2, which is called here as a temperature function since it's a heat transfer problem. So you multiply here this N1 into T1 plus N2 into T2. You get this equation, which is called a temperature function equation. Sometimes people may ask, what is the equation temperature function? So write this once. Okay. So thank you, gentlemen. So now we have seen this in presentation. The shape function or temperature function, how to derive it with respect to one-dimensional heat conduction problem. Any doubts, you comment here in the comment box. You ask the questions here, I'll try to answer to your question. So thanks a lot for the support, gentlemen, and please subscribe to our channel Surgery Academy and get more videos, get learn, and get expand your knowledge. Thank you.